Welcome to Scientific Notation Multiplying and Dividing. Before we get going, just want to recall that when you multiply a number by a power of 10 that has a positive exponent, you're multiplying by a very big number and you'll have an overall very big number. When multiplying it by a power of 10 with a negative exponent, you are multiplying by a very small number, and so your overall number will be very small as well. A few things to anticipate today. We are going to use the commutative property of multiplication to rearrange numbers and multiply the leading numbers together, as well as the powers. And then we'll also need to look to express our answer in scientific notation. Let's go ahead and take a look at our first example. We have 2 times 10 to the third power times 4 times 10 to the 20th power. Please remember, when we are multiplying, we can rearrange the numbers that we're multiplying and get the same outcome. So let's group our leading coefficients or constants. 2 times 4, and multiply that by our powers, which we have 10 to the third times 10 to the 20th. Now we'll go ahead and simplify. 2 times 4, our constants, equal 8. And then if we look at our powers, because they have the same base 10, we can go ahead and simplify by adding the exponents. So 10 to the third plus 20. Finally, we get 8 times 10 to the 23rd power. This is in scientific notation. Our first number is between 1 and 10, and our second number has a power of 10 with an integer exponent. Let's go ahead and take a look at a more advanced problem. We have 3.5 times 10 to the negative second power times 3 times 10 to the fifth power. This is not more advanced because of the decimal. In fact, we're going to take the same approach as we did with the last problem and group our 3.5 and 3, the leading numbers, and multiply that by the powers of 10. 10 to the negative second times 10 to the fifth. From here, we'll go ahead and simplify. 3.5 times 3 is 10.5. Multiplying this by the powers of 10. If we have that same base of 10, we can go ahead and add the exponents to simplify, and we get an answer of 10.5 times 10 to the third power. This answer is not okay. Can you see why? If you notice, this first number is not between 1 and 10. It is greater than 10. So we need to rewrite this power so that we get the number between 1 and 10. From here, I suggest that we rewrite this in expanded or standard form and work our way back into scientific notation. So if we start with 10.5, pulling on what we've done the past couple of days, you can go ahead and expand this by moving the decimal 3 places to the right. 1, 2, 3. Fill them in with zeros if you need. And now we need to get that number between 1 and 10. If you notice, that number between 1 and 10 is 1.05. And it takes 1, 2, 3, 4 moves to get back there. So instead of 10.5, we'll have 1.05. We had 4 decimal place moves, so that will bring us to an exponent of 4. Our number is in scientific notation. We have a number between 1 and 10, and we have that power of 10 with an integer exponent. And keeping in mind, this is a big number, and our exponent is positive, so we've written this correctly. Let's go ahead and take a look at our final example with division. We have 3 times 10 squared divided by 6 times 10 to the fifth power. With multiplication, our first step was to multiply the constants, so with division, our first step will be to divide the constants. So we're going to go ahead and group 3 divided by 6, and we're going to multiply that by grouping the powers similarly, 10 squared divided by 10 to the fifth power. From here, we can go ahead and simplify. 3 divided by 6 is 1/2, times, if you guys recall, with multiplication, we added the powers. With division, powers with the same base, we can subtract the exponents. So we have 10 to the 2 minus 5. That gives us a final power of 1/2 times 10 to the negative third power. However, this is not okay. Do you see why? The leading constant or coefficient is less than 1, and we need to make it between 1 and 10. So again, as with the previous example, I recommend that we write this in standard form and get it back into scientific notation. So starting with 1/2, the negative 3 tells us that we need to move the decimal 1, 2, 3 places to the left. If you guys see, we want the decimal to be behind the 5 so that our number is between 1 and 10, and that's 5. So if we move from in front of the 0, we move 1, 2, 3, 4 places to get that number 5 between 1 and 10. And so we get 5 times, we move the decimal 1, 2, 3, 4 times. It is a very small number, and so we will have a negative exponent, and now that is written in scientific notation.